Hello folks, this is John Baugh again. This is lecture number 12. On the syllabus, you'll notice it says that we're covering inheritance. It also says GUI applications. We won't really start those until next week. We're just going to cover inheritance this week. I figured that would, especially with your capstone project being assigned, it is a lot of extra stress right now, so I figured that you could use the extra relief on some of these. So today we're going to cover inheritance, which is chapter 12, 10, sorry, chapter 10, and we'll talk a little bit about polymorphism and a couple other things related to that, superclasses and subclasses and different things that are important to those trying to learn Java. So let's get started. So we'll learn what is inheritance. We'll learn about calling the superclass constructor, overriding superclass methods, protected members, chains of inheritance, the object class, polymorphism, abstract classes and abstract methods, and interfaces. So first of all, we have to understand from a conceptual level what is inheritance. So we don't even worry ourselves with programming until we understand what does it mean, what is it going to be, and why are we doing it, what's the reasoning behind using inheritance. So real-life objects are typically specialized versions of other more general objects. For example, the term insect describes a very general type of creature with numerous characteristics. Grasshoppers and bumblebees are insects. They share the same general characteristics of an insect. However, they have special characteristics of their own. For example, grasshoppers have a jumping ability and bumblebees have a stinger. Grasshoppers and bumblebees are specialized versions of the general insect. So here's what inheritance could look like. We have the insect, which contains attributes and methods that are shared by all insects, so behaviors and characteristics of insects. Then you have specializations, bumblebee and grasshopper. So bumblebee would contain the attributes of, if we had classes here, the bumblebee would contain attributes and methods that are specific to the bumblebee. Grasshopper would contain the attributes and methods that are specific to a grasshopper. So to understand inheritance, we should define what an ISA relationship is. So the relationship between a superclass and an inherited class is called an ISA relationship. For example, a grasshopper is an insect. Okay, I would say an here, but is a insect. Poodle is a dog. Car is a vehicle. Okay. A specialized object has all the characteristics of the general object plus additional characteristics that make it special. For example, the general dog, poodle is a specialization. So poodle is a dog, but it has maybe fluffier tail and fluffier fur. It has different characteristics, shorter height. Grasshopper can jump. Car is a vehicle. Vehicles just, they can get you from one place to another, but a car has four wheels, is within a certain capacity of size and height and all this other stuff. Maybe that's what makes it a car versus a truck. Doesn't have a bed, in the back, etc. In object-oriented programming, inheritance is used to create an ISA relationship among classes. So remember, classes allow us to do classifications of items, of entities such as insects, grasshoppers, poodles, dogs, cars, etc. So with inheritance, we can extend the capabilities of a class. Inheritance involves a superclass and a subclass. The superclass is the more general class, and the subclass is a specialization of that superclass. The subclass is based on or extended from the superclass. And just as a side note, in some literature and in other languages, especially, say, C++, the superclasses are called the base classes because they provide base functionality and attributes. And the subclasses are called derived classes because their attributes and behaviors, they are derived from the superclass, and then they extend upon those attributes and behaviors and add new ones. The relationship of classes can be thought of as parent classes and child classes. So inheritance. The superclass, or the subclass, inherits fields, which are the data, and methods from the superclass. Remember, this is the more general one, the superclass. The subclass is more specialized. So the more specialized class, the subclass, inherits fields and methods from the superclass, the more general class, without any of them being rewritten. Okay? New fields and methods may be added to the subclass. The Java keyword extends is used on the class header to define the subclass. Here's an example. Let's say we have a graded activity right here. It has a score of type double. It has setScore, getScore, and getGrade as public member methods. And then we make a specialization, or a subclass, called final exam. This has additional information as well as the score. It has num questions, points each, and num missed. And in addition to setScore, setScore, getScore, and getGrade, the final exam also has a final exam constructor. It has get points each and get num missed. So the superclass contains those attributes and methods that are shared by all graded activities. And then the subclass, the more specialized class, final exam, contains those attributes and methods that are specific to the final exam class. They inherit all private or non-private attributes and methods from the graded activity class. So the examples that we'll go over, there are a couple in the book. I have a project set up for right now. I'm going to create our first class, graded activity. Graded activity. And we'll put it com.close. Grade stuff. Okay. So we've got a private field here called score that gives the numeric score of a graded activity. Then we have setScore. Okay, which sets the internal data score. We will also have a getScore method, which will retrieve the information from the object of the class. We just return the score there. And then we have char getGrade. So we haven't really dealt a lot with char, but remember char is a single character. So just fill in those right now. And then we'll assign it a value. I'm going to set it to just an empty character for right now, just so we can get rid of some of the errors. So if the score is greater than or equal to 90, then we'll set the letter grade equal to an A. Else if the score is greater than or equal to an 80, the letter grade is equal to a B. Else if the score greater than or equal to a 70, letter grade equal to a C. If the score is greater than or equal to a 60, the letter grade is equal to a D. And then otherwise, the letter grade is equal to an F. All right, we'll put a single blank character in there just so it gets rid of the errors. The next thing we're going to do is we're going to create a grade demo class. So let's do this. We'll call this one grade demo. This one will be for the purpose of actually running and utilizing our grade activity. we'll make a string input. And we'll have double test score. Okay, so we'll create a graded activity. And we'll call it grade. Graded activity. Alright, so we've created an instance of the class that we just made. Give a test score. So input equals j option pane.show input dialog. For this one, we're going to say enter numeric test score, and then the test score is going to be equal to double dot parse double. I'm going to pass it the input that came as a text from the j option pane. Then we use our class. We set the test score, and we display the letter grade. So we have j option pane, show message dialog. We'll say the grade that test is. Grade.getGrade. Alright. And then, of course, since we're using j option pane, system dot exit. Note that in order to use j option pane, you need to have javax.swing.joptionPane. So if I'm going to run this, you'll notice that the j option pane pops up. Let's say we put a 75, hit OK. Let's say the grade for that test is a C. Run it again. Give it a 94. Grade for that test is an A. And we'll do one other boundary test because it's 20%, didn't do so good that day. Grade for that test is an F. So, pretty good. So far, so good. The next thing we're going to do is we're now going to just, what we've done so far is we've just described and displayed what occurs in a class, but we can also use inheritance. So we're going to use inheritance and base it off of this graded activity here. I'm going to go here, create a new class. We're going to call this final exam. So final exam.java appears here, and I'm going to write extends graded activity. This is the keyword you use in Java in order to implement inheritance. So it extends graded activity. So not only does it have the stuff that graded activity does, it also has more. So we've got num questions, points each, and num missed. So we'll create we're going to create a constructor here. We're going to have numeric score. You're going to set num questions equal to questions, num missed equal to missed, which were passed in. We're going to calculate points and the numeric score. So we're going to say points each equals 100.0 divided by a number of questions. So I give points each. We'll assume that it's the same number of points. And then we have the numeric score is equal to 100, which is the percentage, minus the missed times points each. Makes sense? Because in this case, we're utilizing the number of points each that are passed in and the number of questions. So we calculate the points each, and then we base that on the number that they missed. So then what we're going to do is we're going to call set score numeric score. Now, set score is inherited from graded activity. So we can call it as if we had defined it in here, but we don't need to because it's already been defined for us. We also are going to define additional methods here. This one's going to return points each. And get unmissed is going to return unmissed. So that's our example of inheritance. Now, we should probably write a demo so we can exercise this and show you how it works here. Questions. Yeah, it's not used directly, but okay. So I'm going to create a new class here. We'll call this Final Exam Demo. And this time, we're going to create the main method. And the main of the input, questions, which would be the number of questions, and then number missed. So input is going to say J option pane dot input dialog. Notice it automatically added the javx.swing option pane for us. If you aren't using Eclipse, you have to add it manually if it's not an IDE that does it for you. But it's good to know where these objects, classes, and methods live, so you should know where they are. So we're going to say how many, put down here, questions are on the final exam. Alright, so we obtain that value from the J option pane, and then we have to parse using integer.parse int. That's the input. That makes sense. Questions. Yeah, questions, not question. There we go. That's better. Then what we're going to do is we're going to get number of questions missed. The one up here is just get number of questions. And then down here we'll do the number of questions missed. So we'll say input equals, we're going to reuse this input here, show input dialog, so how many questions did this student miss? Right? And we have missed equals integer dot parse int. We want to pass it the input. Right, so create a final exam object. I'm going to say final exam equals new final exam. I'm going to pass it questions and the number missed. So remember the class, I don't know why I keep picking question, the class final exam, when we create an object of this type, will actually perform calculations and keep the information for us. So we want to display this test results. We'll say J option pane. This time we're not getting input, so it's just show message dialog. The first thing we're going to put is each question counts. So the exam. Oops, I'm sorry, the first parameter should be null. I'm just going to do that and then type null, comma. Okay, each question counts as exam.getPoints each. Alright, I'm going to say points. Now you can do a \n, remember that causes there to be a new line, so we're causing there to be multiple lines just for organizational purposes in the J option pane. So we'll say the exam score is exam.getScore. I'm going to say another \, the exam grade is exam.getGrade. Okay. And then of course system.exit, since we're using J option pane. Alright, so we're using the getGrade and getScore that belong to what class? Do they belong to the final exam class directly? Were they described here? Were they implemented here? No, they were implemented in graded activity. But since graded activity is the parent or the superclass of final exam, the subclass, that means we have access to all the public methods. It's as if we had defined them. So this is a form of software we use. So let's run the program. How many questions are on the exam? We'll say 100. How many did the student miss? 23. And it'll say each question counts 1 point. The exam score is 77. And the exam grade is a C. All right? Pretty cool. So now what we're going to do is move on a little bit and try to describe some more things. All right. So we've got members of the superclass that are marked as private superclass. They're not inherited or accessible by the subclass. They exist in memory when the object of the subclass is created. They may only be accessed from the subclass by public methods of the superclass, or protected methods, but that doesn't say that yet. Oh, from the subclass by super. Yeah, okay, yeah, that's right. Members of the superclass that are marked public are inherited by the subclass and may be directly accessed from the subclass. When an instance of the subclass is created, the non-private methods, okay, meaning public or protected, which we haven't gotten to, of the superclass are available through the subclass object. Okay, so anything that's not private is available through the subclass. So if I say set score like I did earlier in the example, set score actually belongs to the superclass, but we can call it through the subclass because it is not private. Constructors are not inherited. When a subclass is instantiated, the superclass default constructor is executed first. The superclass's constructor, to access it, the super keyword refers to the object's superclass. It is a keyword. Okay, just like this points to your own object, this points to the object's superclass. Super does. The superclass constructor can be explicitly called from the subclass by using the super keyword. There are plenty of examples in the book. I won't go over them right now. I'll leave that as an exercise for you to kind of mull through them and try to figure them out better. Calling the superclass constructor for parameterized constructors defined in the superclass. Okay, parameterized constructor. That means a constructor that has parameters. Remember, constructor has the same name as the superclass, or as the class it's in. For example, final exam is a constructor because it has the same name as the class, and it's parameterized because it has two parameters. So this is a parameterized constructor of the subclass in this case. So here we say if a parameterized constructor is defined in a superclass, the superclass must provide a no-arg constructor, or the subclass must provide a constructor, and subclasses must call a superclass constructor. So calls to a superclass constructor must be the first Java statement in the subclass constructors. So you can override superclass methods. A subclass, remember the more specialized version, can have a method with the same signature, so same name, same parameter, number, and types, as the superclass method. The subclass method overrides the superclass method. This is called method overriding. So we've got the more general superclass graded activity, and we'll say, let's say we create a curved activity. This method gets score, even though it's defined in the superclass. If we define it again, since it has the same signature, in other words, number, parameters, and types, same exact thing, this method is a more specialized version of set score in the superclass graded activity. So this is the one that will be called. Recall that a method's signature is the method's name and the data type method's parameters in the order that they appear. A subclass method that overrides a superclass method must have the same signature as the superclass method. An object of the subclass invokes the subclass's version of the method, not the superclass's. So if you have an object of type curved grade or curved activity, and you have a graded activity up here, you have set score. If I say curved activity A equals new curved activity and then say A dot set score, is it going to call this one or is it going to call this one? According to this, it will call the subclasses version of the method, not the superclasses. It's called overriding, not overloading. It's called overriding. A subclass method can call the overridden superclass method via the super keyword. So if I say super.setScore, for example, set score on raw score times percentage, there's a distinction between overloading a method and overriding a method. Overloading is when a method has the same name as one or more methods but with a different signature. When a method overrides another method, however, they both have the same signature. Both overloading and overriding can take place in an inheritance relationship. Overriding can only take place in an inheritance relationship. So it can only take place in an inheritance relationship. Preventing a method from being overridden, if you use the final keyword in front of a method name, that will prevent overriding in any of the subclasses. So if I try to override it, it's not going to happen. If a subclass attempts to override it, the compiler will generate an error. So we've got public and protected. These are the access specifiers, access modifiers we talked about for a long time. There's a third access specification called protected. Protected members of the class may be accessed by methods in the subclass and by methods in the same package as the class, but they can't be accessed outside. A protected member's access is somewhere between private and public. Using protected instead of private makes some tasks easier. However, any class that is derived from the class or is in the same package has unrestricted access to the protected member. It is always better to make all fields private and then provide public methods for accessing those fields. If no access specifier for a class member is provided, the class member is given package access by default. Any method in the same package can access the member. This gives tables of what happens and who can access what. So you might want to review this. It's on slide 22. Chains of inheritance. Well, a superclass can also be derived from another class. So it might be when we talk superclass, subclass, we're talking about a relationship between two classes. So a superclass of one class can also be a subclass of another. In this case, for example, graded activity is a superclass of pass-fail activity, but is also a subclass of object. And pass-fail exam is a subclass of pass-fail activity. It's not a superclass of anything else that we can see, but pass-fail activity is a subclass of graded activity. So that's called a chain of inheritance or an inheritance class hierarchy. So classes are often depicted graphically in a class hierarchy. It shows you the hierarchy of inheritance relationships going on between the classes. So graded activity has final exam, which is a subclass of it, and also pass-fail activity, which is a subclass. Furthermore, pass-fail activity has pass-fail exam, which is a subclass of pass-fail activity. The object class is a special class in Java. All Java classes, all of them, are directly or indirectly derived from a class named object. Object is in the Java lang package. Any class that does not specify the extends keyword is automatically derived from the object class. I'll read that again. Any class that does not specify the extends keyword, so pretty much all the classes we've dealt with thus far, except for the one example today, is automatically derived from the object class. So every class is derived from the object class either directly, which means like this, if you don't specify extends at all, that means that the compiler actually adds, essentially, extends object at the end here. This always extends object. So every class is derived from the class object. If I say extends some other class, well then that class either extends another class or it automatically extends object. So ultimately everything extends object. Because every class is directly or indirectly derived from the object class, that means that every class inherits the object class's members. For example, toString, which we've used on many different occasions, and equals. Both of these are inherited from object. So toString returns a string containing the object's class name and a hash of its memory address. By default, you can't overwrite it. The equals method accepts the address of an object as its argument and returns true if it's the same as the calling object's address. So polymorphism. A reference variable can reference objects of classes that are derived from the variable's class. Polymorphism, you have to understand inheritance to understand polymorphism. There are essentially the three pillars or three major characteristics of object-oriented programming. You have encapsulation, which means that we can hide the implementation details and abstract out those. We can bundle together also the fields, which are the attributes or characteristics, and the behaviors, which are the methods inside of a class. That's where encapsulation comes in. Inheritance means what we just learned, that you can inherit behaviors and data from a superclass. And polymorphism shows us that we can use a reference variable, and we can reference actual objects that are derived from that variable's class. For example, if I have graded activity and I have a variable named exam, I could say new graded activity, which is exactly what we'd normally expect. But also, graded activity is a superclass for final exam, for example. So we could say graded activity exam equals new final exam. So this looks a little bit squirrely because this doesn't match this. But the statement creates a final exam object and stores the object's address in the exam variable. This is an example of polymorphism. The term polymorphism means many forms. Poly, many, morph, form. Okay? Polymorphism. In Java, a reference variable is polymorphic because it can reference objects of types different from its own as long as those types are subclasses of its type. So these are examples. We could say exam 1 equals new final exam, exam 2 is pass-fail exam, exam 3 is pass-fail activity, and then pass-fail exam for exam 3. The graded activity class has 3 methods. We've got setScore, getScore, and getGrade. A graded activity variable can be used to call only those 3 methods. So that is the drawback to using polymorphism in this fashion, is that you can only call the methods that were defined in the data type of the reference variable. So for example, since this is graded activity, I can only call getScore and getGrade. I can't call getPoints each because that belongs to pass-fail exam, or rather pass-fail activity ultimately. But I can't call this because it isn't defined in this reference variable type graded activity. There's also a concept that's used with polymorphism quite frequently called dynamic binding. That means if the object of a subclass has overridden a method in the superclass, if the variable makes a call to that method, which one's called? That's the question. And the subclass's version is the one that will be run. So even though they both have setScore, if both of these classes define a setScore, graded activity and pass-fail activity, they both define a setScore, then that means that it will actually call pass-fail activity's version, the subclass's version, not the superclass's version. All right, so Java performs dynamic binding or late binding when a variable contains a polymorphic reference. So it's the object's type rather than the reference type that determines which method is called. So the actual object in memory, not the reference variable, so the variable name. It is the object's type, the one that's been created in memory with new. So abstract classes. Abstract classes cannot be instantiated, but other classes can be derived from it. An abstract class serves as a superclass for other classes. you cannot instantiate it. So I can't say whatever the class name is equals new whatever the class name is. If it's abstract. If it's abstract, that would be a compiler error. An abstract class has the sole purpose of being derived from. So a class becomes abstract when you place the abstract keyword in the class definition. Abstract method is a method that has no body, and it has to be overridden in a subclass. Not can be, it has to be. So an abstract method is a method that appears in a superclass but expects to be overridden in a subclass. An abstract method has only a header and no body. So for example, if you have access specifier like public, private, public, we'll say abstract, void, some method, and then a parameter list, there would be no body. There's just a semicolon here. Notice that the keyword abstract appears in the header and that the header ends with a semicolon. So public, abstract, void, set value. Any class that contains an abstract method is automatically abstract. So if you put any abstract method in the class, that class becomes abstract, so you cannot instantiate it. If a subclass fails to override an abstract method, a compiler error will be generated. Abstract methods are used to ensure that a subclass implements the method. A similar to an abstract class, a similar entity is the interface. So in Java, an interface is similar to an abstract class that has all abstract methods. Now, this is not to be confused with graphical user interfaces like components like JOption pane that we've talked about and things like that. That's not the same thing. So although that does allow the user to interface with the program graphically. In this case, an interface is similar to an abstract class that it has all abstract methods. So it cannot be instantiated, and all of the methods listed in the interface must be written elsewhere. So the purpose of an interface is to specify behavior for other classes. An interface looks similar to a class, except it uses the interface keyword instead of class, and the methods that are specified in an interface have no bodies, only headers, and are terminated by semicolons. So this is a general format. All methods are specified as public by default. Class can implement one or more interfaces, but it can only inherit from or extend one class. Okay, but you can implement several interfaces. So to implement an interface, you use the implements keyword. That's basically your class. For example, this final exam 3. Final exam 3 is making a contract with the relatable interface and saying, I will implement all the methods you specified. If you don't, you're going to get a compiler error. So what about fields and interfaces? Interface. In Java, not in some languages you cannot declare fields at all. But in Java, an interface can contain field declarations, but all the fields in an interface are treated as final static. Okay? Because they automatically become final, you must provide an initialization value. So you have to provide a default value. In this interface, for example, doable, not double, doable. Notice I had to specify the values. Even though I specify int, they are actually final static ints. So that means you cannot change them, and they are available directly from the interface. Any class that implements the interface has access to these variables. Implementing multiple interfaces. A class can be derived from only one superclass. So Java does not support what we call in other languages multiple inheritance. So C++ does. Now you might think that's a good feature, but there's a reason there are reasons they removed it, because multiple inheritance is kind of sloppy, and you can accomplish everything you want by just using interfaces in Java, which we don't really have in C++. So Java allows a class to implement multiple interfaces, but only extend or inherit from, derive from, one superclass. When a class implements multiple interfaces, it must provide the methods specified by all of them. To specify multiple interfaces in class definition, you just separate them by commas. So I would say my public class, my class implements interface 1, comma, interface 2, interface 3. These are only on separate lines by chance of fitting it on the slide. When the slide maker did this, you do not have to put them on separate lines, but you can. It sometimes makes things cleaner. So interfaces in UML. So what does this look like in UML? Well, this is kind of wrong the way they wrote this, but an arrow, the arrowhead should be clear. It should be empty. There should be nothing in the arrowhead. It should be white. And just have an outline of an arrowhead. That represents inheritance. So final exam 3, inherits from graded activity. A dashed line with an arrow indicates that there is an interface being implemented. Okay, so that's how you describe it in UML. UML is a language, non-language specific modeling language to show what a certain class does or inherits from, things like that. So I'm looking for the page real quick because I want you to have access to to know exactly where to go. Yes, page 681. So again, it should look just like the inheritance arrow with a white arrow, basically, or an arrow outline with white inside of it. On page 681, you'll notice that is for to implement or to show that you're implementing an interface, not extending a class. That's why it's dashed. So that's the difference. Polymorphism with interfaces. Java allows you to create reference variables of an interface type. You can never instantiate an interface just like abstract classes. An interface reference variable can reference any object that implements the interface, regardless of its class type. This is another example of polymorphism. So, for example, to retail item, reference variables item 1 and item 2 are declared in the example code, which is in the book. Item 1 variable references compact disk. Item 2 references DVD. When a class implements an interface, an inheritance relationship known as interface inheritance is established. So we would say that compact disk could be a retail item, and also DVD movie is a retail item. Okay, so that's what we call interface inheritance. It's not true inheritance because it's not inheriting from a class. So again, reference to an interface can point to any class that implements that interface. You cannot create an instance. So like I just said, you can't say this. If you have retail item as an interface, I can't say retail item equals new retail item any more than I could do it with an abstract class. All right. When an interface variable references an object, only the methods declared in the interface are available. Explicit typecasting is required. Okay, in other words, you have to explicitly convert one type to another to access the other methods of an object referenced by an interface reference. All right. So that's pretty much all you need for today. The capstone again has been posted. Continue to ask questions, and I will peruse the questions. I will try to answer them on the discussion board and also through email. So if you have any questions, just send me an email or comment on the discussion board and try to work through different problems. And have a great day. Thanks. Bye.